In this video we're taking a look at another calculation involving moles, and it's just another domino. So up to now you would have dealt with for example, the molarity domino. And what we mean by that is, if you think back, I gave you a card, and on one side of the card we had the word molarity, and when you turned the card over, on the back we had the words moles per litre, like the dominoes that you get with the dots on them. So mole per litre. That's what molarity is. If we're now talking about gases, we have another card that we can add into the mix. We actually have two cards that we've not yet talked about, and that is that there is molar volume is the card. And the molar volume at STP, which stands for standard temperature and pressure, the molar volume is going to be the number of moles in a given amount of litres. So 1 mole takes up 22.4 litres. So you can write that either way that you like. It's 22.4 litres over 1 mole, or 1 mole per 22.4 litres. And that's specifically at STP. So that's what all of these questions are revolving around. But you will see sometimes in the exam papers, they won't give you STP, they'll give you something else. And they will always tell you that the molar volume is this, and they'll give you a value, and you use that one. And what you need to know is that you're going to create a little domino in your mind, molar volume, 1 mole per whatever it is litres. So in the scenario we're looking at first here, we're being asked to find the volume of gas at STP in the following scenario. So it's 4.5 moles of hydrogen gas. If I want to work out the volume, I need a connection between moles and volume. And that's going to be our new domino, molar volume. So I have 4.5 moles, and I need to figure out now, what do I need to do to go from moles into the volume, which is going to be the litres. So I actually want the litres to be on top. So what I'm going to do is I'm actually going to say divide this by 1 all over 22.4. And the reason why I'm saying divide is because when we divide by a fraction, we actually end up flipping it. So it's actually going to be 4.5 moles multiplied by 22.4 litres all over 1 mole. And what happens now is you get the moles to drop out, and you've just got 4.5 by 22.4, and if we multiply that out, I will get 102.15 litres. So 4.5 moles of hydrogen gas, of H2 gas, will take up 102.15 litres. And that's it. It's just another card to think about in the calculations around the mole. So it works exactly the same as our molarity, which was a mole per litre in terms of concentration. Now we're talking about molar volume, which is a moles per litre card as well, but it's not per litre, it's 1 mole per 22.4 litres. Or rather, flip it around, we're talking about the number of litres per mole that a gas takes up. So this would be talking about concentration, and this would be talking about our gas. And that's it. So it works the exact same way otherwise. 56 grams of oxygen. So I actually have another card that I need to bring in, and have a think about it. What this card requires, if we're talking about molar volume, it requires moles. And if I'm going to start talking about moles of oxygen, how do I go from grams into that? Well, grams and moles are connected through the molar mass card. So there is another card that I can draw out over here, where on one side we have the words molar mass, and on the back, you might remember, if I've got molar mass, on the other side I've got grams per mole. Okay. So you just mentally have to think of those. You might find it useful to draw it out at the top of the page or on a spare sheet of paper for yourself, just to remember what they are. But grams per mole. So first I'm going to convert 56 grams into the number of moles. So again, I actually want the moles to be on top. So I'm going to end up dividing by this fraction. But first, I need to figure out the molar mass, and you should be pretty nifty at this point. So finding the molar mass of oxygen. So you go to the periodic table and you look at the atomic mass. The atomic mass of oxygen is 16, and what you're going to do now is you're going to double that 16 because oxygen gas is O2. And if it's O2, it means there's two 16s. So we're actually going to have 56. And 2 16s is 32. So I said I was going to also divide. So I'm going to have 56 divided by 32 grams per mole, which works out to be 56 multiplied by 1 all over 32. And I'll keep the units in because it helps me to think about this. So I've got 56 grams multiplied by 1 mole all over 32 grams. And this is going to drop out. And if I do that calculation out, I'm going to get 22. Not yet, actually. I'm not going to get that. What do I get if I do 56 divided by 32? 56 divided by 32 for me is 7 over 4, which is 1.75. So I don't get the 22 yet for a second. That's 1.75 moles. Keeping track of the units here will really help you. How do I go from moles then into a volume? What's the connection? It's a gas, so I need the molar volume card. So 1 mole gives us 22.4 litres. Well, I don't have 1 mole, I've got 1.75 moles. So what I'm going to do to that is I'm going to multiply it by the 22.4. So multiply by 22.4 litres over 1 mole. So I flipped the card upside down, and this is what I'm going to get. So I'm going to multiply it. And if I do 1.75 by 22.4, I end up with 39.2 litres in that question. So that's that for that question. So we keep going, and the next one is now talking about the number of molecules. So I'm not talking about grams, I'm not talking about molarity, I'm talking about number of molecules. And this is another domino, a domino we would have talked about before, and that's Avogadro's number. So Avogadro's number talks about numbers of molecules. So on one side of your card, Avogadro's number, and on one side you've got the name, and on the other side you're going to have what it is. And what it is that there is 6.022, so 6.022 by 10 to the 23 molecules per 1 mole. So that's how many atoms or molecules there are in 1 mole of a substance. So if I want to get molar volume, first thing, or if I want to, I want to work with molar volume. If I want to do that, I'm going to need to make sure that I first had the number of moles. So I need to go from molecules into the number of moles, and I'm going to do that through Avogadro's number. That's the connecting piece. So first we're going to work this out. So it's 5 by 10 to the 26. That's how many molecules I have. That's molecules. This is molecules over moles, but I want moles to be on top, so I'm going to flip it and I'm going to multiply. So I'm going to multiply by 1 mole all over 6.022 by 10 to the 23. And that's going to end up with the units for the number of molecules dropping out. So I'm going to work that out now. I'm going to have 5 by 10 to the 26, and I'm going to divide that then by 6.022 multiplied by 10 to the 23, and that leaves me with 830.2889406. That's now the number of moles that I have. So I've got quite a large number of moles of our substance here. And what I'm going to do next is I'm going to introduce my molar volume, because that's what I wanted in the end. So I've got 830.2889 moles. And how do I change that into the volume of a gas? Well, I go through the molar volume, and that is that it is 22.4 0.4 litres for every 1 mole that I have. So I'm going to multiply, and then the units drop out and I'll be left with litres. So I'm going to multiply that out. My answer multiplied by 22.4, and I'm going to get 18598.47227. And we can round that to our 1 decimal place or to significant figures, whatever they normally ask for in the question. I haven't specified here. So let's round it to 2 decimal places. So I'm going to have 18598.47. So I've just used another card there. So it's all about the dominoes. The process is exactly the same over and over and over again. So just take your time with the cards and write them out if you need to, and play around with the units. That's what I would recommend. The next one is asking us to find the mass of gas. So if we started out with the number of molecules at STP, and then I wanted to go all the way right back to the mass of gas, how am I going to do that? So first thing I can do is convert it into moles. That's usually what you always want to bring it back to, is bring it back to moles. So if we have 9.0 by 10 to the 17 molecules of helium, how do I go from molecules into moles? Well, if we go back up, the card that we have for that is Avogadro's number. So I'm going to have to divide by that Avogadro's number. So it's going to be divide by 6.022 by 10 to the 23 molecules per 1 mole. What happens when we divide it, actually, remember, is that is going to flip. So this becomes on the bottom and this goes on the top. Oops, that goes on the top. So just move that up. And then remember, it becomes multiply. And then I get out the unit that I want. So if you play around with units, it honestly makes it easier, in my opinion, rather than ignoring them. The molecules will kind of, the units will tell you the story. So follow the units as you go. So the molecules will drop out, and then we're going to have 9 by 10 to the 17. Then I am multiplying that by 1 all over 6.022 by 10 to the 23, and if I do that out, I'm going to get 1.4945 by 10 to the minus 6 moles. If I'm in the number of moles now and I want to get back out to my mass, I need to think about how do I convert between moles and mass. And I'm thinking about molar mass and that card. So molar mass is the grams per mole. So I would need to figure out what is the grams per mole for helium gas. So helium has an atomic mass of 4. So 4 grams per mole. So I don't need to do anything here. I don't need to flip it. I just need to multiply it directly with my 1.4945 by 10 to the minus 6 moles. And if I multiply that out, that drops out with that, just like in algebra. And then you multiply 4 by that other answer that I just got. And what I'm getting is 5.978. So I'm going to round it to 5.98 by 10 to the minus 6 is what I'm getting for that one. So the next one, if I had 11.5 litres of chlorine and I want to find the mass. So first thing, you always want to bring it back to, you're probably noticing the pattern at this point, is you want to bring it back to moles. And if you bring it back to moles, then what we're going to do, or how we're going to do that, is go through the molar volume card. And what we know is that if I have 11.5 litres, what I need to do is multiply that by 1 mole all over the 22.4 litres. So what will happen now is the litres will drop out, and then I'll be left with 11.5, so 1.5 divided by 22.4, and what I'm going to get is 0.513392 recurring and it keeps going. But I'm not finished yet. That tells me the number of moles. I wanted the mass, so now I'm thinking about how do I go from the number of moles into mass, and the connection is through molar mass. So I need to figure out chlorine gas is Cl2. Chlorine has a mass of 35.5 according to the periodic table. So I'm going to put that into my calculator. 35.5 by 2. And I'm going to get out 71 as our value. So 71, and the unit on that for molar mass is the grams for every 1 mole. But in the question, I don't have 1 mole. I've got 0.59, 0.51, 3392, keeps on going. So what we need to do now is we need to use this combined with this. And how do we combine the two of them? Well, we track the units. So if you keep track of the units here, you want to get rid of the grams. You want to get rid of the moles, and you just want to have grams. So I've grams on the top, that's where I want it to be. I've moles on the bottom, so that means the other number must have moles on the top, and it does. So it's nice and straightforward for us to do that. So if I multiply that now by 71, I should get out the number of grams of chlorine gas that I have. So I'm going to have 36.45 grams of chlorine gas. So all about going back to moles. That's what all of the questions are going to revert you back to. Keep track of your units. That's really going to help. And know your dominoes and what the different definitions are. So what's Avogadro's number, what's molar volume, what's molarity, what's molar mass, and know what the units are. And I promise you it'll become a lot easier. It's just repetition from here out. Once you've got a hang of the units and how the dominoes work, it gets a lot easier. Alright, so that's that. Practice, practice, practice from there out. The Chemistry Live workbook is a great place to start with the practice from here.